Activity 1. Solving an equation with multiple variables. Examples 1 and 2. Example 1. We have the equation 28 equals 5x plus 3. We want to solve the equation for x. We'll write our equation out. 28 equals 5x plus 3. We're going to use reverse order of operations and subtract 3 from both sides as a first step. We can see that on the right-hand side of the equation, subtracting 3 will cancel out our 3's and we'll be left with 5x. On the left side of our equation, 28 minus 3 is equal to 25. We now have 25 equals 5x. We want to isolate x, so we can divide both sides of our equation by 5. This will cancel out the 5's on the right-hand side of the equation, leaving us with x. And on the left-hand side of the equation, 25 divided by 5 is equal to 5. We now have x equals 5, our final answer. In example 2, we have the equation 39 equals 7x minus 5y plus 4. We now have an equation with multiple variables. For this problem, we are being asked to solve the equation in terms of x and evaluate at y equals 7. We then want to solve the equation in terms of y and evaluate the equation at x equals 5. First, we'll solve for x. We have our equation 39 equals 7x minus 5y plus 4. We're going to use reverse order of operations and subtract 4 from both sides. On the right-hand side of the equation, this will cancel out the 4's and we'll be left with 7x minus 5y. On the left-hand side of the equation, 39 minus 4 is equal to 35. We now have 35 equals 7x minus 5y. We'll continue reverse order operations and add 5y to both sides. On the right-hand side of our equation, this cancels out the 5y, and on the left-hand side of our equation, we now have 5y plus 35. Our equation is now 5y plus 35 equals 7x. We'll divide both sides by 7. On the right-hand side of our equation, this cancels out the 7 and we're left with x. On the left-hand side, we can split it up into 5 over 7y plus 35 divided by 7. 35 divided by 7 is equal to 5, so we can reduce that down. And we're left with x equals 5 over 7y plus 5. Now with the equation in terms of x, we'll evaluate the equation at y equals 7. Substituting in y equals 7, we get x equals 5 divided by 7 times 7 plus 5. When multiplying the 5 over 7 times 7, we can see that the 7's will cancel out and we'll be left with 5. So we have x equals 5 plus 5. 5 plus 5 is equal to 10, and we get our final answer, x equals 10. We now have an ordered pair of 10, 7. We'll go back to our original equation, 39 equals 7x minus 5y plus 4, and we'll solve for y. We can start with reverse order operations again and subtract 4 from each side. This gives us the equation 35 equals 7x minus 5y. Now we want to isolate y instead of x, so using reverse order of operations, we'll subtract 7x from both sides. This will cancel out 7x on the right hand side of the equation, leaving negative 5y. On the left hand side of the equation, we'll have 35 minus 7x. Our final step to isolate y will be to divide by negative 5. On the right hand side, the negative 5's will cancel out and we'll be left with y. On the left hand side, we can split it into 35 divided by negative 5 plus 7 over 5x. We can also see that 35 divided by 5 is equal to 7. And our final equation will be y equals 7 over 5x minus 7. Now we'll evaluate for x equal to 5. Substituting 5 in for x, we get y is equal to 7 over 5 times 5 minus 7. We can see that when we multiply 7 over 5 by 5, the 5's will cancel out and we'll be left with 7. So we now have y equals 7 minus 7, or 0. We now have an ordered pair of 5, 0.